Ever scratched your head wondering how computers make sense of words like rocks, rocked, and rocking, all pointing back to rock? Today we are going to unravel that mystery by dividing into lemmatization in natural language processing. What's the big deal with lemmatization? Imagine teaching a toddler that run, running, and ran are all variations of the same action. Now picture doing that with a computer that takes everything very literally. That's where lemmatization steps in. It's like giving our computer friend a language lesson so it understands that different forms of a word actually share the same root meaning. Stemming versus lemmatization, let's understand. Before we jump into lemmatization, let's briefly talk about its cousin, which is stemming concept. Stemming chops off word endings to reduce words to their base form, but it's a bit like using a lawnmower where you really need a pair of scissors. It often results in words that aren't real, like turning studies into a study, like instead of study, it will cut into studi. We have observed in previous tutorials, right? Same way. So lemmatization, on the other hand, is the linguistic participant. It considers the context and converts words to their meaningful base form, known as the lemma. So better becomes good and cars become car. It's smarter, more accurate, and your English teacher would definitely approve lemmatization instead of stemming. Okay. Then we might get a doubt like why not always use lemmatization? That's a good question. Lemmatization is like that meticulous friend who double checks everything. It takes a bit more time and resources. Stemming is faster but rough around the edges. Depending on your needs, speed versus accuracy. You might choose one over the other. That's the thing. Okay, let's go into the code. The theory part I have explained. Let's go into the technical part. First, let's make sure NLTK installed. So this is our common syntax to install an NLTK. And now let's import NLTK and download the WordNet data. Okay, this is the syntax. Let me run this. The black means it's executing and it says downloading and it's completed. Okay, and let's import. We downloaded, right, WordNet. Let's import it. WordNet lemmatizer. Let's import. Okay. Now let's in this syntax. Let's create an instance for this lemmatizer. I executed it. Now let's focus on this lemmatize some words. The below is the code. Let's try lemmatizing now a few words and see what happens. What are the words? These are the words. See, we have running and runs easily, fairly, studies and studied, bigger, best. Okay, let me execute this. Okay, it's executed. See, some words didn't change as we expected here. That's because the lemmatizer needs to know the part of speech, POS, to correctly lemmatize the word. Okay. So to improve the results with POS, part of speech tags, by default, the WordNet lemmatizer assumes everything is a noun. We can get better results by specifying the POS tag. So below is the code for it. See here we are importing POS and executing this. If you see the both results difference, if we see here get WordNet password function, right? This function maps the POS tag written by NLTK POS underscore tag function to a format accepted by WordNet. This one. Okay. Now here we have POS underscore tag word, right? Returns the POS tag for the word. POS tags CJ adjective, N is noun, V is verb, R is adjective. So lemmatizer usage is like we pass both the word and its POS tag to the lemmatizer function. That's what we are doing. So you can see the results also. Here running is running. In this result, running is run. Runs is also run. Let's see here. Runs is run. Okay. Easily, fairly. Studies, study, studied, study. It came as it is here. But in this case, studied became study. Bigger became big. Best is best. There is a good results, right? So why does POS tagging matter? Words can serve different purposes in different contexts. For example, saw can be in a noun, I have a sharp saw. This in verb, I saw a bird. So here in first it is noun and next it is a verb. So without the correct POS tag, lemmatization might not return the expected root word. Got it? So we need to include all these things: adjective, noun, verb, tag. So real world applications again. Yeah, I thought I did not mention here. Yeah, search engines. Also improving search results by understanding the root form of words. Chatbots making bots understand variations of words for better responses. Text analysis, accurate sentiment analysis by understanding word meanings. Let's see lemmatization help us in a quick story analysis. This is the sentence. The leaves on the trees have been falling all autumn. Children played joyfully under the falling leaves. So let's see the result. Okay. This is the original sentence and these are lemmatized tokens. Now notice how the leaves become leaf, trees become tree, falling becomes fall, children becomes, it's again children only, okay, children is children. I thought it would become child actually, it failed. Okay, yeah, it is not 100% perfect. Everything has its own limitations, right? So this is still a better result coming to the stemming, which we have seen in earlier tutorials. So coming to accuracy versus speed, if we discuss, well, lemmatization gives us more meaningful results. It's a bit slower than stemming because it does more work under the hood. It looks up words in a dictionary, like from WordNet, okay, and considers the context. So let's wrap up, guys. Lemmatization is a powerful tool in NLP that helps computers to understand language more like we do. By reducing words to their base or dictionary form, we can perform more accurate text analysis. So next time you are building a chatbot, search engine or any project that involves text processing, consider lemmatization to make your application smarter and more efficient when compared to the stemming. So below is a quick comparison table which you people can see by yourself. Like the second column stemming, third column lemmatization. See, output may not be a real word, always a real word. We observe, right? These results. These are always a real word. So speed is for stemming is faster. For lemmatization, speed is slower because it is doing more other work, right? So context does not consider context this stemming, but lemmatization considers context with pure tags. Okay. Examples for stemming: studies become studi, but lemmatization example: studies become study. That's which is a meaningful word, right? So that's all, guys. Thanks for joining me on this um, chapter about lemmatization. Happy coding and keep exploring the fascinating world of NLP. Let's continue meet again with new session.